Hello, I'm Charlie Scola, and this is ICP5. The objective is to create 5 separate text files containing the text data and perform the following task. 1. Find out the top 10 TF-IDF words for the above inputs. 2. Find the top 10 for the lemmatized input. 3. Find the top 10 for NGram-based input. And then write a simple Spark program to read a dataset to find W2V similar words with a higher cosine similarity for those top 10 words. And you have to do that without NLP, with lemmatization, and with NGrams. So the first thing I did, as usual, is to make sure we have all the stuff installed. So all after you install all this, which is kind of given, we start with the Spark session. So the objective is to do 5 different text programs. So here's 5 different text files that I imported into my Google Colab or my Google Drive, and then what I did was I read it, and in order to put them all together, I used a union. Now this way makes it so that way it's easy to see, but it doesn't give any identification on which one is which, no ID. So I don't know if this is the right way, but it works. So next what we're going to do is we're going to tokenize the input, which is really common for the past few days. So just with a simple tokenizer. So I figure the best way to solve this is to make it into a big function and to pass in the change inputs. So first off, we have to declare all the inputs first before we can declare the functions. So right here is the tokenize input. That's going to be the first one. And now we got to lematize it. So since Spark doesn't have a lematizer, we have to basically save the wordnet into the file and then lematize each word one by one, and then put it back into the data frame, which is we do as so. Next, we're going to do an ngram, and the way that that my main function works is that the main thing you need to pass in is a data set which has the words column. So because this already has a words column right here with the tokenizer, we can't use that for this one right here because it won't pass in the correct things. So basically, we have to tokenize the text again in order to be able to ngram it. And when we ngram it, the real output will be the word. So, did you ever? Well, Ali, Baba. Oh, ngram. Like, yeah. So now is the main function. So we pass in a data set with at least it has to have a column named words, and it will output onto the screen the top 10 words and those words W2V, words to vector. So first thing we do is we apply a transform on the words using the hashing, and then we calculate the IDF with this code that I obtained from the example given in class. So since with PySpark there's no fast way to output the 10 Lima data, at least with this code, I had to find a different way around it. So first what I did was I collected all of the features and all of the words that are passed in. So the features is actually the the IDF file that we calculated right here. So due to this, I have to correlate each IDF to each word. Now the way I did this is very haphazard and is not completely accurate just because of how hashing works. I didn't understand how to make it so that way each word can represent a different hash. But this, with the amount of time that I had, I just basically first changed the number of features to an appropriate number so that way this file, the IDF file, and the word file, the amount of words inside the text, are as closely similar as possible. So the IDF file is actually just one above, which is good enough for a lab, especially if you don't have time. So once we so now that so first we had to find this, which was just subtracting the total words, dividing it by 5 or the amount of text files, and then you go into each data and put in a list the appropriate data. So at the end of it, it has a double it outputs a double matrix, so we have to put in one. So we have to output only one of those files. And then with the words, we do the same thing as well. So once we have both the words and the data, we are able to merge them together. Now I did IDF val first, so that way we can just sort automatically, and then we reverse. So that way the highest value is on top. And since it's a double matrix, the highest the highest number is right next to the word. So next, we just need to get the top 10 values. So to do that, I made the top matrix, not matrix, the top list, and then I just added the top 10 values in this for loop and print them out. So once we find that, we're able to find the word W2V. So to do that, the word to vector. So to do that, we do this code. Because we passed in data that contained the column words, we're able to use this again. So column words in the output result, and it fits the data. And then just a short little for loop in order to show the synonyms and cosine similarities of the words in the input data of all 10 words. So let's do it. So for this data, here are the 10 words that have the highest TDF value, and then here are some here are some synonyms and cosine similarities of those given words. Give, ironic, I've, Al, and Loki. So these are just because of the text file, the data set that I gave for this text file. So this one is at lemmatized. So the text file is now the lemmatization. So as you can see, this is Nolan is definitely different than what was above. And then for NGram is run around. It's basically n amount of words, and then you go to the next one. So never gonna give you up. And as you can see right here, the words are also NGrammed as well because the data is all NGrams. And that is it. This took a long time. Thank you.